Good morning. My name is Marcos Crispino. I am part of the development team in Artec. I work in the area of iOS and everything related to offline synchronization. Today I will talk about how this works. The idea is to make a short presentation and then leave room for questions. If you were in the previous presentation by Martin, you've probably seen something about offline synchronization. The idea is to elaborate a bit more. And as Martin has already explained, the case of offline applications is the case of applications that are occasionally offline. That is to say, applications that can work without connection, but that usually require a centralized server where data are located in order to make changes. In that scenario, the synchronization mechanism is essential, and GeneXus solves that automatically. Synchronization, as we have seen, is always started by the device, so we're talking about receiving, and we're talking about sending, which means sending to the data to the server. So let's now talk about the receive function. The way to configure this is through properties in the offline database object. We can configure when this is triggered, the frequency, and we can specify the granularity. It could be by row or by register. When it is done by table, it sends the whole table from the server to the device. And by registry, you calculate only the things that have changed. This could be done for different scenarios. In the scenarios where you can have table synchronization are those cases where I send few data or things change a lot. And in those cases, it doesn't make any sense to do all the calculations in the server. Let's now see the most interesting case. For this synchronization, we need to know the data in the device. We need to know what are the calculated data as to what it should have after synchronizing. And with that, the server calculates the difference, which is the difference that is sent to the device when synchronizing. This means, obviously, more server processing. The server needs to be able to do that calculation in order to know what data need to be sent to the device, but it has the advantage that this means less network traffic. In order to calculate differences, the server stores the information as to what data was sent to each device. This is done in tables that are created in the server database. They are not accessible from the KB, and they are managed by the generator automatically. And the way of doing compares is through hashes. They are calculated for the whole table in order to know whether it has changed, and it also calculates hashes by register in order to know which have changed. Let's see an example to make it clearer. Let's suppose that we have an application with a table client. Initially in the device there are no data, but the server does have data. We have two clients, and the device begins the synchronization. When the device will synchronize, the server first calculates a hash for the table. This gives us a number. And since it's the first synchronization of the device, it will send all table data together with the hash that the device stores for the next synchronization. Besides from that, information will be stored in auxiliary tables for that hash as to what registers have been sent to the server. After some time, let's assume that there have been some changes. There's a change there, a new register and an erased one, and the device will sync again. Since it already had data, this time it sends a hash for the data set that it had from the previous synchronization. It recalculates a hash in order to be able to compare. Obviously, there's a difference. And with the present information plus the information that had been stored for that data set, it calculates the differences. Based on that differences, it sends them to the device together with the new hash. The device applies the new changes, and then it has the same, it shows the same data as the server. Obviously, the server restores the new hash with a new data set for the next synchronization so that it can calculate differences again. So, on the receive property, we have seen that there are some properties that determine when this is done. It can be done automatically or upon request of the user. We've seen how this can be done, either by table or by register. And we've seen how this works in row algorithms. Let's see the case of the send property, when we send the changes done on the device to the server. And this is different from the previous receive case, because in this case we're not sending registers, we're sending business components. And this is because we want to be able to apply the same business rules in the server. Once again, the configuration is done in the offline database object with its properties. It can be sent automatically when the device is online or upon the user's request. And one case that we still need to solve, but GeneXus solves it automatically, is key mappings. And when I talk about auto-generated primary keys, I mean attributes that have auto-number properties, or primary keys and tables that are calculated through a procedure, for example. Since the calculation is done both in the device as in the server, when it is sent, the key that's generated could be different. Also, those primary keys can be used as foreign keys in other tables, so it's important that the relationships are kept. They might change value on the server. Let's see an example. Let's assume that we have an application. In the device, we enter a client, an invoice corresponding to that client, and then it sends data to the server. When it gets to the server, it will apply operations in the same order. So the first thing that it will do is a client insert, but this time the client is numbered in the server and has a different identifier there. In that case, we cannot insert the invoice as we had it. But since GeneXus knows that those are relational databases, tables, it will update the information before inserting it in the database, and it stores it with the corresponding ID. When this responds to the device telling that everything was okay, it also notifies the new changes done in primary and foreign keys. So the device applies those changes. This is not receiving data. This is just for the data that were sent. It applies the corresponding mappings. And if further on you'll enter another invoice for that client, it will have the correct identifier that it has on the server. Another difference here is in terms of error handling. When you do receive, there might be some errors, some connection errors, for example. But in that case, it's not a serious thing, because you can restart synchronization and it will bring data once again. When you are sending, you can also have connection problems, and then you have to retry sending that further on. But since we're applying business components with business rules, maybe you can get an error in one of these business rules, so the operation cannot be completed on the server. One suggestion for this is try to avoid these things, because it's much easier to solve problems on the server than running the risk of losing data if you were not able to send some information and maybe that was sort of lost in the device. So these are things that might happen, and there's a way for handling these errors. We have mechanisms on the client and on the server sides. In the client, we have an API, which is Synchronization Events API, which allows to query as to which are the business components that need to be sent to the server, and see those that were sent and came back with some kind of error. And we can see the error message provided by the server. So the user on the client side could at least see what happened there. And from a server side, the program that does a synchronization calls these two procedures that can be modified. You can do your own error handling on the server side. The first one is on pending event failed. And this is invoked for every business component that failed. And the other procedure is the after event replicator, which is called upon at the end. And what happens here is you will be sending all the information here, all the data from the complete response of all the business components that came when you received that. And if one of them failed, we could be handling that with this after-event replicator procedure. So, in terms of sending, we've seen the properties, which had already been explained by Martin. We have seen what happens with key mappings, and we have seen what happens and the options that we have for error handling in sending data. Do you have any questions in terms of synchronization or offline? Martin will be here to answer them. Do you have any doubts? Oscar? I'm having synchronization problem in the IDS projects. I'm sorry, but we couldn't hear the question very well. I have some security friends that will be waiting for you outside. This wasn't prepared. Yesterday, we had some problems with synchronization. What happened was the tweets, as Martin said in his previous presentation, had problems in one screen, so images were being loaded, and since this is a slow network and the server was overcharged, now this should have been solved. But if this continues to happen, please tell me and I will tell you what the solution for that is. Any other questions? At some point, do you think about running synchronization by field when you have very complicated tables, or do you do that already automatically? Well, we have thought about that, but we have never implemented it so far. But there's a disadvantage to that. It needs much more processing on the server side and many calculations. They have to be calculated by field, and that might be more expensive. And the device database might have to change more frequently in that case, because remember that it is set up according to the tables that you have. And if we did that at a field level, then the number of changes that could occur on the fields could be much higher, so that would mean many more and frequent changes in the device. We have thought about that, but we need to continue working on it because we still haven't a plan for implementing it. Could that be done upon request of the programmer so that it is not calculated automatically? Yes. Any other question? When there's a synchronization in the device and there's an ID replacement, is that done only at one level? Because there could be a lower level, maybe. No, it should also work for two-level transactions. In that case, you won't be able to replace the level. But this is if the device is not automatic, then you will be entering not so many data. It's difficult. What you've said could happen, and we haven't solved it yet, but it's a difficult thing to happen. If you don't have any further questions, I do have one question, which is about security, which is a question that we receive. What happens with data that are locally stored at a device? From a security point of view, there are various issues here. One, in terms of data communication, which is essential in online applications, because there's an encrypted communication channel. Something that we're often asked about is what happens about the database. This is in the file system of the device, and both in iOS and in Android. If this is in the internal memory of the device, and if the device has a blocking code, then data are encrypted, and this is done by the operating system. In Android, we also have the option of having a database on the memory card, and in this case, it is totally unprotected. Gerardo Canedo will be making a presentation about offline security tomorrow. I think this will be at 11:45 tomorrow. And one recommendation is that if you have really sensitive data, try not to send them to the device. Any other questions? Good morning. In terms of synchronization by specific tables, we have no way of telling it what tables to carry. But we can do is to define conditions. If you have a table which, for some reason, during navigation, for example, it comes through extended tables, but you're not interested in being transferred. You could add a condition so that it is never met. Example, ID -1. But this means that it won't be transferring related registers. We are doing this through extended tables precisely to have data consistency, so that all related data are in all tables. So that means, but in the case of smart devices table, if I have registers, will that be eliminating them? No. Well, if the server knows that the device had registries, for example, because it already synchronized it once, and those registries were sent once, then yes, then it will eliminate them. If the server always said that it didn't need to send registries, and those registries were entered in the device itself, then it won't erase them, because it doesn't know what it has there. Any other questions?
Hola.
Hello. Are there any restrictions about the size that I can have in terms of local quantity of registries in the devices? Well, that depends on the type of registry that you have. Actually, the database has no size restriction other than the memory of the device. Synchronization shouldn't have so many problems in terms of data transference. What we're talking about is a streaming type thing. It processes everything as it is being downloaded. If you have many registries and you have many devices trying to synchronize and many changes in the server, well, then maybe there would be an overload in the server. It's difficult to dimension this because it will depend on your own circumstances. I cannot give you an estimate on that. It does work with many dozens of thousands. For example, we have tested that and it worked well. Any other questions? Well, thank you very much.